Hello and welcome back to this series on Latin NLP with Python. Now, in the last video, we looked at how to take our text, which looked like this, and transform it so that it looked like this. In other words, we learned how to add these accent marks for long vowels known as macrons. This process is known as macronization, and we did it via the macronizer in CLTK. In this video, we're going to move away from the macronization methods and start looking at how to tokenize a text. Now, tokenize, I'm going to do right here, tokenize is the way in which you take a text and convert it into little bite-sized pieces known as tokens. Now, these can be anything from lines like you see in CLTK, but the more common ways in NLP to see tokens rendered is via sentences, word constructions, or word construction links such as noun phrases, prepositional phrases, verb phrases, etc., or individual word tokens. And the reason why we refer to this as tokens is because tokens, it allows us to use a universal term for this concept of a collection of one thing or multiple things. And we also refer to them as tokens because oftentimes in NLP, tokens contain not just the original piece of data, so a word or a sentence or a line, but also a lot of metadata. So if you're dealing with the token of a word, if you're using something like spacey, you'll also have things like parts of speech. Is it a nominative or a subject? Is it an object or an accusative? These are parts of speech. It also might have some very important named entity recognition metadata. So is it a person? If so, does it have a person tag? Is that token a business? So does it have a business tag? These are tokens. And I encourage you to start thinking about tokens as something similar to segments of a text, but something a little different because they oftentimes have all this extra metadata associated with them. So what we're going to do in this video is start dealing with one method of tokenization that comes standard in CLTK, and that is line tokenization. Now, in my personal research, I don't use line tokenization that often because it doesn't matter to me. But if you're working with a early modern edition of a Latin text, line tokenization might be very useful if you're trying to analyze how texts survive in different print editions or in different manuscripts. So I'm going to show you in this video how to tokenize a text by lines using the methods available in CLTK. So we're going to do this by importing the tokenization methods by doing from cltk.tokenize.line. And we're going to import line, important to get the capitals right here, line tokenizer with a capital L and a capital T. That's going to allow us to now create a function that, again, in later videos, we may actually expand upon to make it more complex for more nuanced analysis of our texts. But we're going to make one right now just called, let's call it line underscore tok, T-O-K for token. And we're going to have that function take, once again, a single object that is going to be our entire text. Because what we want to have done to this text is it to be broken up into a bunch of individual line tokens. So what we're going to do is we're going to say tokenizer is going to be equal to line tokenizer, just like we did before. And now for this, we have to pass an argument that is a string. And this string needs to be the language that we're working with. In this case, it's going to be Latin because we're working with a Latin text. And now what we're going to say is we're going to say text is going to be equal to tokenizer.tokenize text. So what we're doing is we're going to pass in that text argument or that text variable, that object, and it's going to be manipulated here on line 50. And when it's being manipulated, we're going to actually return it now. So now all we have to do, let's go ahead and get rid of this stuff from our macronize tutorial in the last video, and now do something like this. We're going to say text is going to be equal to line underscore tok, T-O-K, text. And what this is going to allow us to do is to print off text. And what you see now is a list. Now, this list consists of multiple indices. So let's go ahead and print off index 0, which is of course going to be our first index. And we see that we get the first line. If we look up here, we can see line breaks very nicely in Atom. We see our first line break is in fact right here with the delecto filio and we see that we already have converted it from the I's, the standard I's, the I's and J's, and the U's and V's, like we did in video, I believe it was number 3 or 4. And we see that we were able to tokenize and return individual line breaks. Now, there's other ways in which we can do this without using CLTK. We can, of course, use a split function to go through and just simply split off our text by every instance of /n. And if you follow this channel, you see that I have actually shown you how to do this in other videos. But it's important here to use the CLTK method because, as we're going to see later on, being familiar with the CLTK syntax for tokenizing is going to be very useful when we get to sentence tokenization and word tokenization. But for right now, this is how you go through and simply tokenize a text by line. And if we go through, we can see we start at doleo, and we're going to end all the way over here at proveniat. And if we look at our Latin text, you'll see that it's grabbed this entire section. Why is this useful? Well, if we were to just use the split function, what we're going to end up returning is a list, just like we see here with a split at every line break. But what we're not going to have is we're going to have these double line breaks, which is going to result in index 1, so the second position, being this kind of empty space. We don't want that. What CLTK does is it goes through and it automatically eliminates that so that you only end up with a list of actual lines in a text. This is going to make a lot more sense as we work with tokenization in the next 2 videos. That's going to be it for line tokenization, though. Thank you for listening, and if you've liked this, please like and subscribe down below.